and welcome to today's lesson on image storage and transmission. Today we will have four objectives. Number one, describe what digital information is. Number two, define what a pixel is. Number three, explain the difference between a high resolution and a low resolution photograph. And the fourth one, describe what CCD stands for and how it is used. So to understand how it works in a camera, I just want to basically review how it works in the brain. So the brain plays a big role in sorting, storing, retrieving information. If you guys remember, we have the eyes at the front of the brain here, and then there's the optic nerves. Now, the optic nerves take the information from the eye and it actually transmit it to the back of the brain, to the occipital lobe, and that's where it is interpreted by the brain, and that is what we interpret as vision. And then we can also store that in our brains, and of course the brain's very complex. Well, digital information has some similarities to what we do in the brain, and that is going to be the primary focus of what we're going to look at in today's video lesson. So how did they do this in old photographic negatives? Well, if you remember, we talked about this in previous lesson, that cameras had film at the back of the camera, and then when light came into the camera, the film would be exposed to the light and it would cause a chemical reaction on the film. And then basically through that chemical reaction, you would get an image formed, and different wavelengths of light would react differently with the film, and thus you would have the image and its different colors. Today, we need to get this information, and it's not stored on film, but we need to get it stored digitally, which basically means we need to take that visual information and convert it into numbers. Okay, and we're going to kind of explain how this happens by going through an example of stadium images. So if you can imagine, here we have a stadium, and there's thousands of small cards of different colors, and they're used to form one big image. And every person in the stand holds a colored card, or at least every person in this frame of reference here. And you'll see that in this particular case, we've got white cards, and then I think these individuals here, where it says the V here, they aren't holding a card. So if you will, that could be considered not having any information. Okay. And so when we view the picture from across the stadium, from afar, these cards form a large picture. And in this case, we've got the Olympic rings, and we have white cards, we got red cards, green cards, black cards, yellow cards, and blue cards. Now, if you think about a stadium, how it's organized here, each section has rows and seats. So it's like an XY grid. So along the bottom would be the X, so the seat number would be like the X, and then the row number would be like the Y coordinate. So each chair, each seat has a specific coordinate that can be assigned to it. So there's numbers right there. So if, for example, this was row 1, seat 22, let's say, there's 1, 22, those are two numbers that give you the digital address, and then there must be another number that will give you the color. Okay, so what do digital images do is they put all this information together. So when a computer receives an image, it divides the picture up into small elements called pixels. Each pixel is assigned coordinates, just like the row and seat numbers of the stadium. And now the computer has reduced the picture to a series of numbers. Okay, so that's these X and Y, and so they each have a number for that particular pixel. And this allows us to pull up that particular pixel. And now when we assign coloring to this here, we also need to assign a value to each pixel that corresponds to a certain color. Okay, so we've got numbers for the location or the address, and then there's a value or a number assigned for each picture that will make that pixel a particular color. And if the image is black and white, then the value assigned to each pixel can correspond to a shade of gray instead of a color. So now we're going to talk about resolution. And when we're talking about resolution, we're really talking about digital image quality. The quality of a digital image depends on the number of pixels, okay, or the size of the pixels. So if you can imagine, we had a photograph, same size photograph, with just a few large pixels, the image would appear poor and grainy. So if you can imagine, this image here is got fewer pixels, and so you can actually see some of the pixelation in the details. But if you were to make those pixels smaller and have more of them, so if we were to have more pixels that are smaller, we would get a higher resolution. If there's less pixels and they're bigger, then we get a poor resolution. Okay. Now, I'm going to have you guys watch this video on your own, 4 minutes, 10 seconds here, but it's an excellent video on explaining resolution a little bit more detailed. Okay, but basically all capturing devices as the ones you see here, they all basically do the same thing. They use a charged coupled device. And a charged coupled device is a sensor. It's simply light enters the camera lens, okay? It falls onto a CCD grid, which is basically a grid that's just got millions of pixels on it. And each pixel is assigned a coordinate. And when light strikes each pixel, that pixel, the CCD for that pixel, measures the color and brightness of the light, thus assigning at that particular point in time, it automatically assigned its coordinate number, its color, and its brightness stored as numbers in the memory's device, or sorry, the device's memory card. And then this information is basically ultimately converted into a series of ones and zeros. You'll find out as you learn more about digital is that it's all about being on and off. And you can learn about binary code and whatnot. It's beyond today's conversation, but if you want to learn more, you could definitely look that up and learn more about it. But ultimately, we take an image and we break it down into ones and zeros, and that's what we are transmitting. Okay. If you want to learn more about charged coupled devices and how they work, some pretty neat images in here and animations that I'm beyond my capabilities of reproducing for you guys, but please have a look at that video. It is excellent. I found it quite enjoyable. Okay, and then the last part of today is transmitting digital images. And I guess it's not a main objective today, but really I think you need to appreciate that in the past, in order to get an image from, let's say, my house to Leduc, I would literally have had to have printed it out, put it in an envelope, and ship it by mail to get to Leduc, or drive it there, or physically transport it there somehow. Nowadays, with digital information, we can take that digital, so that photo that's broken down into digital information, the ones and zeros, the numbers, and we can transmit it through our Wi-Fi, through our satellites, and this can be transmitted throughout the world in literally seconds, if not milliseconds, and and then it can be reassembled. So basically, you need to put that digital information back together again. But basically, that's what our computers do all the time. Whenever you open a file, that file is all just ones and zeros. And then the computer program that opens that file just has the script or the code to how to interpret that information, and it rebuilds your photograph. So in my lifetime, I've actually had some images that were stored on an old 3.5-inch floppy disk, and it was so old. I remember it's so old. The image probably came from the early to mid 90s sometime, and I was trying to back up some of these images around 2005, 2007, sometime in there. And I found these old discs, and I couldn't even open up the files anymore because the data on the discs, which was it's kind of magnetized onto the discs there, it had lost its ability to hold the information. And so basically I had some images that actually came up as half images. So a little bit of a side note there, but interesting. Okay, another advantage I should mention here of digital imaging is that the digital cameras can be created to collect different parts of the spectrum. So, for example, here we see a thermogram. Okay, this is infrared radiation, but satellites can collect. So the cameras that are on, like the Hubble Space Telescope, for example, can collect images from all ranges of the electromagnetic spectrum, including radio, broadcasts, etc. And so, as you learn more about electromagnetic spectrum, as you get into physics 20, I believe, you'll understand that a little bit more. But yes, there's a wide range of electromagnetic spectrum. A lot of it is invisible to our eyes, and a thermogram is a great example of that. Thermogram is looking at the infrared part of the spectrum, and basically it's emitted by all objects emits infrared, but the intensity of the infrared is a good indicator of how much heat is being transferred from that object. So in this image that you're seeing on here, you can see that this counter is relatively cool. It's kind of got blues and purples. And then you can see up at the top where there's probably a light or something on there is bright white. And then we get, as the radiation levels or infrared levels cool down, we get into oranges and yellows. And of course, this bright white up here, maybe that's a radio or something like that that's on. And it could be reflecting light from a light that gives it its additional heat, or it could just be the fact that it's been running for a while and it's generated some heat since it's been turned on. Cool. So in closure, here's what you need to really be able to do today. Number one, describe what digital information is. Basically, information that is stored as numbers. Number two, can you define what a pixel is? And I know that in the video here, I might have skipped over that part. I just want to recapture it again for you here. A pixel is called a picture element. Okay, a picture element. And you would think that'd be PICTEL, but it's actually been shortened to PIXEL. So pixel is a picture element. Okay. And then explain the difference between a high resolution and a low resolution photograph. So just, I think the big thing here is remember that high resolution, you're looking at image that has smaller size pixels and better quality. So many small size pixels. And then, if you will, low resolution would be the same size of image with larger sized pixels, but fewer of them. Okay, so it's really important that the image size stays the same. Same image size with lots of pixels, better quality. Same image size with fewer pixels that are larger, less resolution. And then number four, make sure that you understand that CCD stands for charged coupled device. And it is basically the sensor on a camera that takes the light information and converts it into digital information that can be stored and transmitted. All right, you guys, so that is it for today. If you have any questions, feel free to get in contact with me through email or our other lines of communication. And we'll see you next time, you guys. Have a good day.